Curvilinear motion is when you have it is your object is not moving at a straight path. It is moving in a curve against the gravity, right? Something like this. For example, if you have a ball, something like this, right? If there is a velocity which is applying here, initial velocity at a particular angle theta, right? This ball will be moving like this, right? And it will be hitting ground. Let me consider this my location, right? It will be hitting something like this. So this type of motion we call it as a curvilinear motion, right? So how to solve a problem related to these things? So if you have a velocity at a particular angle, right? What you have to do, right? So this is the next topic. So here the thing is, it is like you have a velocity. So what you do for forces, if you have an inclined force, you will be resolving it, right? So same concept you are going to use here. So what I'm going to do is I'm going to resolve this. When I resolve it, I will get 2. So let me consider in terms of ux, right? So velocity in x direction and you have velocity in y direction. There are 2 velocities now when I resolve this, right? So what I will get? So if I want velocity in x direction, that will be equal to resolving this. If I resolve this, ux will be u cos theta and uy will be u sin theta. So these are the 2 terms. So we got, right? So we say this as horizontal velocity, right? And this one is vertical velocity, right? So previously we have only one. So now we are once we are resolving it, you will get 2 components. So horizontal and vertical. So both components you have, right? So now for horizontal velocity, what are the things you can able to identify? So for horizontal velocity, you can able to identify what is the distance. So what is the distance? It is traveling. You can able to identify what is your a. Let me consider this as x. You can identify what is the value of x, right? So in that case, so what I can do, I can write the 3 equations. What are the 3 equations? We know the 3 equations. V is equal to u plus at, v square is equal to u square plus 2as, s is equal to ut plus half at square. So I'm going to use these 3 equations and I'm going to write it accordingly, right? When it is horizontal, your s is equal to x, right? Your distance traveled is x distance. And your acceleration is 0. There is no horizontal acceleration, right? Only vertical. Your gravity alone is acting as an acceleration. So your acceleration is 0. In that case, what happens to my equation, right? My equation will be v is equal to u, right? Which means I can write as vx is equal to ux. I'm substituting here, right? I'm substituting here. X a is 0. This gets cancelled. So vx is equal to ux, right? That is my first equation. Second equation, I'm substituting v square is equal to u square x, which means same v is equal to ux, right? Because the acceleration is 0 here, it gets cancelled. So this 2 is same here. This 2 is same for the equation 2 also. So I'm not going to write it again. So leave it. Third equation, yes, I can write as x is equal to u into t. So this becomes 0. So which means ux into t. So this is my equation. This is my equation. What I am achieving for this particular horizontal velocity. Next, let us go for vertical velocity. When I consider vertical velocity, you may have a distance which is y relating. So it may be here, it may be here, whatever location, whatever the location of your y, right? So in that case, I can write s is equal to y. Where acceleration is You can able to see that your uy is upward direction, your acceleration is minus 9.81, minus 9.81, right? So these are the two datas. Let us substitute the same in this. So what you'll get Vy, I'll get three equations. So what is my equation? Vy is equal to Uy minus 9.81t. That's my first equation. So Vy square is equal to Uy square minus 9.81 into 2. Yes, yes is y, right? I am writing that. This is my second equation. Third equation is y is equal to uyt minus 4.905. So 9.81 by 2 t square. This is my three equations. So this is another set of equation, right, which we can use to identify this values, right? So hope you can able to get a sets of equations here, but no need to muck up these things, right? What I have done, I have used these things, these datas. Only this data is important, right? This data is important. Others, you just substitute in your usual formula and you can get it directly, right? So the problem here is you have to look after carefully and you have to write your data accordingly, right? For example, let me consider you have a ball here and you are throwing it like this, and I do it to identify what is the height to achieve this. Sorry, achieve this height, right? Y. My initial position is here, right? My initial position is here. Here, my S is positive. Here, my S is positive value. My acceleration is negative, right? I may have the same case like this. So this is my initial point, my ball. I'm hitting this, I'm throwing this ball, and the ball is traveling like this, and it is falling like here. My Y is here. So note, இது வந்து ball. This is my reference point. இங்கிருந்து y distance is positive towards upward direction. So positive. ஆனா plus y. இந்த இடத்துல அப்படி கிடையாது. So இந்த is my initial position. My final position is downwards. So here s is minus y, and my acceleration is same, minus 9.81. There's no difference because when you resolve this, right? When I resolve this, what I will get? I will get uy like this, right? So which means negative. When it is downward direction, yes is positive because it is towards that particular um, direction, so it is positive, right? If it is upward direction and your y value is downward, which means negative. So make sure the direction is very, very important in your location. So initial location and final location, right? So and also the arrow. So if you are throwing upward towards that direction is positive, away from the direction, opposite direction is negative, right? You can substitute it accordingly, right? Hope you can understand this, right? We consider here. So it is observed that the time for a ball to strike the ground at B is 2.5 seconds. So when it strikes here, it is 2.5 seconds. Determine the velocity VA. So they have mentioned, so actually this is U, right? So velocity UA and angle theta at which the ball is thrown. This is my question. Okay, so what I'm going to consider is, let me consider this is my location. You are throwing this ball. So let us identify based on this location, what is your values, right? So I want X value and what is my Y value, right? X is where X distance is 50. It is given. So it is 50. Y, so from here, it is downward direction. So minus 1.2. Y is minus 1.2. So what I am going to do is, I'm going to resolve this. So you have ux and uy, right? So let us identify what is ux. Ux is equal to V. So I consider VA as V, right? V cos theta. And Uy is equal to V sin theta, right? Ux is V cos theta and Uy is V sin theta, right? These are the two values. Now, let us identify what is horizontal value, horizontal velocities. So when I say horizontal velocity, I am talking about Ux. So whenever I consider Ux horizontal velocity, your acceleration is always zero, right? So I use that three formulas. I write the three formula here. V is equal to U plus AT. V square is equal to U square plus 2AS. S is equal to UT plus half AT square. So for horizontal equation, I can use only
X
your
is equal to
first and
UX
third one,
data.
right? So what I can say, I can say V is equal to UX. Of course, this is VX. VX is equal to UX, right? Next, X is equal to UX into T, right? These are the formula. I know what is the value of X. X is 50. 50. So 50 is equal to UX into T. They are given what is the time. The time taken to reach is 2.5 seconds. They are given that. So I'm going to apply that. So T is 2.5, right? So in that case, what is your UX value? 50 divided by 2.5.
20, 20 centimeters per second.
We are getting 20 meter per second, right? So we identify what is the value of Ux, right? So this term is over. Now we'll go for the next one, vertical velocity. When I go for vertical velocity, right, your gravity, your acceleration is minus 9.81, right? So this is the value I'm going to use. I'm going to use the same formula. Vy is equal to Uy minus 9.81t. This is my first equation, right? Second equation, Vy square is equal to Uy square minus 2 into 9.81 into y, right? So I'm going to substitute here. So to identify, is it possible? So before substitution, just look after it whether you have one unknown data. So I think Vy is an unknown data, Uy is also another data, unknown data. So let it be like that. So we will substitute it later. So next, S is equal to UT. So Y is equal to UYT minus 9.81 by 2 T square, right? So this values, all the values are known. So I can use this, right? So your Y is minus 1.2. Your Y is minus 1.2 is equal to UYT. So T is also known. So the time taken is 2.5 seconds. So T is 2.5. So Uy into 2.5 minus 4.905 into 2.5 square. Solve this. What is your Uy? Sorry,
7825.
11.7825 meter per second, right? Okay, I got these values, right? I got Ux value and Uy value, right? These are the two values which is identified, right? So I am going to divide Uy divided by Ux. This is equal to Uy. What is Uy? So V sin theta divided by Ux V cos theta, right? So Uy is 11.7825 divided by Ux. Ux is 20. is equal to V gets cancelled, right? So you'll get tan theta, right? So can you able to identify what is the value of theta? Theta is equal to tan inverse of whatever the value we are getting here. Theta is equal to 30.5 degree. So this is 0.589. Okay. Once you identify this
Yes, sir.
theta, you substitute in any of these values. Let me consider ux is equal to v cos theta, right? Ux is 20. 20 is equal to v cos 30.5. So what is your v value? So 20 divided by cos 30.5. So what is your v value? 23.2 meter per second, right? So you are, a person is hitting a ball, right? So you have to identify what is the minimum initial, same procedure, initial velocity and what is your angle theta, so that it is crossing the fence, which is 3 meter height, right? The fence is around 3 meter height, so it has to cross that. So that is the problem, right? So let us identify what is the x distance and y distance. X distance is 6 meter here, y is 3 meter. So these are the two datas I have, right? So it is not negative. Make sure it is not negative because along the same direction. So it is a positive value. So now I can resolve this. I will get ux and I will get uy, right? Same procedure. There is no difference. Okay. So let me go for ux. Ux is u cos theta. So we call this as v naught. So v I am calling as u, right? U cos theta, and uy is u sin theta, right? Let us identify for horizontal. Same procedure. Okay, let me go for horizontal velocity. So when I consider horizontal velocity, right? So you have this datas, right? So v is equal to vx is equal to ux. That is my first data. So there is no other change. Next, x is equal to ut plus half at square, right? So x is equal to ut, uxt. This is my other data. So x is 6 here. So 6 is equal to ux into t, right? I have no other data here, right? So this is my equation 1, right? And we have that as equation. So because we don't have any other data related to this, so we will stop here, right? We'll proceed with the next one. So next one is your vertical velocity. And we go for vertical velocity. When I consider vertical velocity, Vy is equal to Uy minus 9.81 T. This is my first equation. So in this, I think I can't able to apply any of this because all are unknown data. So let me have it like that. Next, Vy square is equal to Uy square minus 2 into 9.81 Y. The second data here also I don't know all the values. So only two values I don't know. So leave it. Last one, Y is equal to UIT minus 9.81 by 2 T square, right? So I think y value is 3, right? Y value is 3. So 3 is equal to UIT minus 4.905 T square. So this is other equation. Right. So now I think we are stuck somewhere, right? So what we can do now? Still, I am going to try something else with respect to equation 1. Let me go for equation 1 now. Equation 1 is uxt is equal to 6. What is ux? Let me substitute that. U cos theta. So u cos theta t is equal to 6, right? So which means I am getting t value. So now I will call this as 6 by u cos theta. u into cos theta, right? From equation 1, what I have done is from equation 1, I just substitute the value. So ux is u cos theta, and I identify what is the value in terms of t, right? Similarly, let us go for equation 2. So from equation 2, right? Equation 2 uy. So 3 is equal to uy. So uy we will be calling in terms of u sin theta. So let me call this as u sin theta into t. So uy into t minus 4.905 t square. This is my equation 2, right? So now what I'm going to do is I'm going to substitute this 3 in this equation, right? Let me identify what you will get. So 3 is equal to u sin theta into t. I can substitute as u by u cos theta. So 6 by u cos theta minus 4.905 t square, right? T square I can consider as 6 square, which is 36, divided by u square cos square theta, right? So same thing, right? T I am substituting as u by cos theta, right? So which will be 636 by u square cos square theta. You are getting something like this. Okay. So let me do this. So let me just simplify a little bit. So in this case, if I simplify, your u gets cancelled. So sin theta by cos theta, I am getting tan theta, right? So 6 tan theta minus. So what is 36 into 4.905?
176.58.
176.58 divided by, so u square cos square theta, right? So this is what I am getting. Now let me bring this on the other side, right? So let me bring this on the other side, or I want my concentration is on this u square, right? I want u square on one side, right? Others on the other side, so that it will be easy for me to identify, right? So to do that, what I'm going to do is I'm going to change this accordingly. So let me consider like this. So 176.58 divided by u square cos square theta is equal to 6 tan theta minus 3. So this is my value, right? So something I'm getting like this, right? So now what I can do, I can cross multiply, right? If I cross multiply, what I will get is, so I will get like u square cos square theta into 6 tan theta minus 3 is equal to, right? So this is 1, right? Is equal to 176.58. Okay. So which means, so I want u square. So u square will be equal to 176.58 divided by cos square theta into 6 tan theta minus 3. We are getting an equation like this. I want u. So u is equal to root of 176.58 divided by cos. So okay, I'll write it as cos square theta, right, into 6 tan theta minus 3, something like this. Okay, this is my overall equation, right? Let me consider this, right? So in the problem, it is clearly mentioned that minimum initial velocity. That's why I have identified u, right? The purpose of keeping this u on one side and the others on the other side is they need minimum u. So minimum velocity, right? You got an equation here, right? So when your value u will be minimum in this case, right? When u will be minimum, right? When the denominator, cos square theta of 6 tan theta minus 3 is having a higher value, greater value, then I can say that your u will be a minimum value. Right? Any clarification on this?
No, sir.
Right? Now, this is my overall term. Right? So now the only way in solving this is by using trial and error method. Right? So we are going to apply trial and error method. Right? So I think this is the first time we are doing this. So what we are going to do is you have to type it in the formula. Right? You have to type it in the formula and you are going to identify what is the value of these things. Right? So as usual, I have taken this calculator. So your main calculator. So I'm going to type this formula. So only this term, not the entire term, only this term. So what I'll do, I have to put. So your only variable here is theta, right? So theta I will call it as a, right? Theta I will call it as a. Okay. So what I do to going to do is open the bracket first. I'm going to apply open the bracket. Then enter this cos theta, cos, right? Enter cos. Then press alpha button, this button, alpha button, then a, which is -1. So this minus button, right? So now close the bracket, then give x square. So because of this, what you will get is cos a the whole square. You will get something like this. Okay. So now what you do again, you press into button, you press you press into button, right? Then again you open another bracket. So opening your bracket here. Okay. So now you put 6. So press 6. Again into button. So into, right? Next, press tan, right? Then alpha, right? Alpha, and again minus, this minus symbol, right? So you will get 6 tan theta. So tan x, right? Then put this minus, then 3. Then close your bracket. So based on this, you will get open 6 into tan a minus 3. You will get something like this. So overall, you will get like this. So cos a the whole square into something like this. Now, what you have to do is going to do is I'm going to identify what is the value of a, right? So press calc button. So press calc button. So to identify the value of a, right? So calc button. So it will ask you what is your a value, right? So you know that this angle theta, what we are discussing about this theta, right? This theta will be somewhat here, something like this theta, something, right? This is from 0 to 90. It won't go more than that. Okay, you know that your maximum theta will be from 0. 0 means it is horizontal. It is also not possible. 90 is vertical. That is also not possible. So it will be in between these two. So I'm going to enter some value, right? Let me check it out. Let me put 50. If I put 50, what is my answer? If I put 50 as A and if I press equal to,
1.71.
so you're getting 1.71, right? Okay, let it be. Now I'm going to change my value. So let me put 80. Can you tell me what is the value? 0.935. So it is reducing. So when I increase my angle, your value is reducing, but we need higher value, right? So, okay, what I am going to do is I'm going to put 20. Let me put 20. So you are getting minus 0.72. So that is very much less. So you identify something like it should be greater than 20, right? Approximately, right? And it should be less than 80 also, right? So it will be in between 20 to 80, something approximately, right? Okay. So instead of 50, let me give 45. What is the value?
1.5.
It is reducing. Okay, so 1.5. Okay, let me reduce a little bit. Let us identify. What about 30?
0.348.
0.348. So which means when a decrease from 50, it is reducing a lot. So I'll get a conclusion that it will be in between these two something. So 1.7 is the maximum and 0.93, right? Okay. So in that case, so let me increase it. So it will be from 50 to 80. So I'm guessing something based on these values. So let me put 70. Can you tell me what is the value for 70°?
1.577.
1.577. So which is lesser than this 50. So let us come closer to this 50, right? Let me give 55. What is the value?
1.832.
So you are higher value. So which means it is greater. It will be in between these two, 55 to 70 approximately. So this is what we called as a trial and error method. So let me give 60.
1.848.
So 1.84. It is increasing. Very good. So 65.
1.762.
So it is reducing 1.762. Okay, which means it will be in between 60 to 65. I'm guessing it will be in between the 60 to 65. Okay, let me give 61.
1.839.
It is reducing 1.839. So 1.4, it is reducing. Okay, 60.5.
1.844.
Same. So can you guess what is the, let me take 4 or 5 decimals. What will be the values of 60 and 60.5?
Sir, for 60, 1.848, sir.
Okay, in 1.848, 60.5. Okay, okay, this is
1.844.
1.844, which means decreasing. Okay, then let us consider, let me consider 59.59. Let us consider 59. What will be the value?
1.853.
1.853. Okay, still it is greater. 58.
1.8539.
So which is greater than this? Let me put 58.5. So the last value.
1.8540.
So okay, 1.854. So it is nearly to this. So don't go beyond that. That is enough, right? So you need some approximation. So I identify that your theta value will be 58.5° in order to get this value a higher value, right? So this is mainly approximated, right? So we now we conclude something. So our identified what is our theta value, right? Why theta value is around 58.5 approximately, right? So no need to worry about it. So you have to show some trial and error method and it will be nearer to this. right? In order to achieve minimum u, because your u is u, this theta, this entire term is in denominator. So only if your denominator is having a higher value, you will get minimum u. Your u will be minimum. So what I identified, I consider only the denominator term. We identified in trailer method, we identified which is the maximum value. So our maximum value is around 1.854 something, right? It doesn't matter. So this is my maximum value, right? So for this, the theta what we achieved is 58.5. So this will be the theta value, so that to achieve minimum initial velocity u, right? Minimum initial velocity u. Are you getting it?
Yes, sir.
Yes. Now we identify what is our u value. So u is root of, right, 176.58, 176.58 divided by this value, right? So this I am going to substitute it here. So which is 1.854. So can you identify what is the value of u? So 9.759. So this is meter per second. This is the initial velocity, right? This is the minimum initial velocity, right? Okay. So this completes this problem. So you have a volleyball player serves a ball with an initial velocity of 13.4 meter per second and at an angle of 20° with horizontal, right? So it is given in the diagram. Determine if the ball will clear the top of the net. So the first question is whether it will clear the net, right? Top of this net. That is my first question. Second question is how far from the net the ball will land. So where it will land. What is your distance, right? So what is this distance? They're asking what is this distance? X. Okay. So we have what is our initial velocity u. So initial velocity which is given us for 13.4 meter per second, and the angle theta is also given which is 20°, right? So when I construct here, I am going to resolve it into two. One is ux, other one is uy. These are the two terms. So if I consider ux is u cos theta, right, which is equal to 13.4 into cos 20°. So what is your ux then? 12.591 meter per second. Similarly, let us identify uy. So uy is u sin theta, right, which is equal to 13.4 into sine 20°. So what is your uy? 4.583 meter per second, right? So we identify this two. Now we'll proceed one by one. So let us go for horizontal velocity. So when you look here, the first thing is I am going to concentrate on this position, right? What is this position? Because I have to identify what is my s distance. If I know what is my height, what is my height? If it is more than 2.43 meter, then it is passing, it is clearing that net. That is my first question, right? So since I want this position, my x value is this one, which is 9. Okay. So we know that I'm going to use the two formulas. Vx is equal to ux into t. Anyway, I'm not going to use this. Next is x is equal to ux t, right? So x is equal to ux into t, right? What is the value of x in this case? So value of x here is it has to pass this 9 meter. So your x is 9. So 9 is equal to ux is we already identified, which is 12.591 into t, right? So you can identify the value of t. What is the time taken for crossing this 9 meter, right?
0.714.
So 0.714 seconds. This is the time taken for crossing this 9 meter. Okay, now we'll go for the next step, which is vertical velocity. So I'm not going to concentrate any of this. I'm going to concentrate only on this height, right? So which means my final equation, right? Last equation. So y is equal to uyt minus 4.905 t square. This is nothing but s is equal to ut plus half at square, right? So half a is minus 9.81. We know that. So I am substituting like that. So I am getting something like this. So my aim is to identify this y at that particular location. So y is equal to uy. We know we already identified 4.583. Let us consider 4.583 into t. So time is 0.714 minus 4.905 into t square 0.714 the whole square 771 meter, right? So don't think that your y is lesser, so which means it will be hitting this net, because here you have to look after this one. So my y distance is from this location, right? So make sure your y distance is from this location. From this, it is a positive value of 0.77, right? So totally it is 2.1 plus 0.77. It is, I think it is greater than 2.43, right? So from the ground, height from the ground is 0.771 plus 2.1. So what is the value? So 2 point,
2.8.
right? So 2.871 meter, right? So this is greater than 2.43 in that case. So you can say that, so it is passing, right? It is passing the net, right? So this is my answer. Okay. Hope you can understand. We are considering only from this initial point, right? What is the distance? Okay. So this is the first one. So as first one we are completed. Next, how far from the net the ball will land? How far from the net the ball will land? Okay, that is my next question. Let me consider this as case two. I will solve it again, right? So we will identify what are the other things we are having, right? Let me put a line. So now first let us go for a horizontal velocity. My horizontal velocity, I'm going to concentrate only on the third equation. X is equal to ux into t. So I don't know what is the x here, right? X is equal to ux value I know, which is 12.591 t. 12.591 t. So this is my equation one. Let me consider, right? So x is not known now because it is hitting the ground, right? From here, it is hitting the ground. Uh, Actually, the x what I am finding is this entire x. Right? This one we have to identify later. Okay, this is what I am identifying now. So later we will subtract 9 and we'll identify from the net. So because they're asking how far from the net, right? So we will subtract it and we'll find out. Okay. Next, vertical velocity. Again, I'm going to consider only the last equation. So last equation, I ought to identify what is my y distance from initial position to the final position. Right? Initially it is here, final location is here, which is minus 2.1. Right? My y is minus 2.1. It has to hit the ground, right? So in that case, I will use the same equation. So only thing is my y value is minus 2.1. Minus 2.1 is equal to uy. What is your uy? 4.583. So 4.583 t minus 4.905 t square. So let me bring these things on the other terms. So you'll get 4.905 t square minus 4.583 t minus 2.1 is equal to 0. What is the value of t? Yeah, you can use your calculator to identify this value.
Sir, 1.271 one value, sir.
1.271 or and the other value
Minus 0.336.
0.336. So this is not applicable, right? So this value is not applicable because negative time is not possible. So only this value. So which means my t is 1.271 seconds, right? Now I can identify what is the value of x. Substitute in equation 1, right? Substitute it in 1, right? So it will get x is equal to, so u is 12.591.
16.460, sir.
So your x is, which will be 16.46 minus 9, right? What is the value?
7.46.
7.46 meter. So this is my distance, right? So my distance here is 7.46. Any doubt on this? Okay, in that case it will be 7, right? So, okay, if this is 16, so this will be 7. So I have two more little bit complicated problem. We will be discussing it tomorrow.